So we have this get generation, right? We're trying to write a function where we send in some value, a year, maybe like from 1925 on. And then it'll return the sequence of characters, millennial, generation X, baby boomer, whatever. So we start with if, I think I got this from the web somewhere, so I don't know if the years are correct, but it'll serve for a good example. So we'll say if year, hold on, let me go here before I forget, just the basic structure for this one. So this one's an if else if and finally else. So that's like what you'll see like in common programming languages. If, do this. Else if, do that. Maybe another else if, do this. Maybe another else if, do this. And finally else, right? So like, for example, if we were dealing with grades, right? Like if 90 to 100, then A. 80 and less than 90, then B, right? Something like that. And this is an if-else if statement. In Python, it's if elif else. Okay, I think that's, so notice it's elif, right? So it's one keyword together, not like else if like other programming languages. But it works exactly the same as other programming languages, so we shouldn't be worried about like, well, am I gonna have to learn new stuff? No, like you learn how this works. The only new stuff you'll learn, you have to learn for Java, C# or C++ is I have to remember that I have to use if else if and not if elif else. So let's go back over here. And we're like, okay, if year greater equal to 1996 and year less than equal to 2014. I guess I did this example back then, I don't remember. Then we want result equal to, according to wherever I got this info, centennial, I'm not sure. So we have result, and we will return results, okay? So we have this piece here, and then we go into our test case. So let's go here, and we're like, okay, let's def test get generation. This is required. And then we say self assert equal get, we spell out generation, we send in the year 1997, and that should return the sequence or the string centennial. Again, notice here it's complaining, doesn't know what get generation is, so we go to quick fix, add, and it'll add the get generation for us right here at the top. So now it knows what get generation is. So we have this piece here. We go to run test file to run it. So let me clear this piece here. Clear the terminal, run the test case. So we have get generation right here. It's okay. So good, get generation. And nothing that we've not seen before, right? But we want to be testing code as we write code, and maybe here we can say, okay, so let's do the other branch, self.assert. This is a test case, equal get generation, and then I'm going to put the year like 1980 here, and that should return millennial. Okay. Let's see. Okay, unknown word, whatever. Okay, And I'm going to run the test case. Let me clear this piece here. Run test case. And we shouldn't be surprised that it failed, because it's telling us here that quote quote is not equal to millennial down here. So if we go look at the code, decisions.py, we set result to quote quote, and then we cover centennial years 1986 through 2014. I used the number 1980, so we haven't coded for that. So now the test case is failing. So what we want to do is we want to write just enough code to make the test case pass. And that just enough code is using the elif piece, right? So we say elif, and then we use the other branch. We say year greater than equal to 1977 and year less than equal to 1995. If that's the case, then we want result equal to millennial. And we go back to run test. Let's go down here, clear the terminal, go up here to the upper right and hit play. And notice now our test case passes. So why do we do this, right? So in programming, right, there's the thing that, like, if you want to make the program just good enough, like just good enough to work and meet the requirement that the customer wants. In this case here, we were just good enough. We let the test case do our development or driving our development, like it's guiding us. And we can be like, okay, so what if, assuming the testers or we came up with some test data, right? So here I'm like, I'm going to use get generation with the year 1970. And that should give me generation X, right? So generation X. I guess millennials with 2 N's or what? Maybe that's what it's complaining. Let me, if I change it there, then I have to change it here. Okay. So then I come back to my test. So I'm saying if I use 1970, I should expect generation X back. I know we haven't coded for that. That's okay. We're like, let me run the test case. Run test. I'm still like thinking C++. And again, down here, notice quote quote is not generation X. And it's quote quote because we set it to quote quote and nothing meets the criteria here. So then it's like, I'm just going to give you back quote quote. Now we can create the other piece of code that'll make our test case pass. So we say year. This may seem cumbersome, but like in the end, you're writing fewer lines of code and you're getting your test cases done as you write code. So we'll say greater than equal to 1965 and year less than equal to 1976. And if that's the case, then we want to say result equals generation X. Run test. Clear terminal. Upper right, we run. And notice we're good, like our test case passed, meaning like we wrote good code so far. And let's go again and we'll continue this exercise just to show you that it's by the time we finish writing the code, we would have finished testing our function, and then we can be very confident that our function will work when we use it in the main program. So what are we after now? Year 1950. So year 1950, that should give us a boomer, right? So baby boomer. And again, make it fail. So go here, make it fail. Why do we say make it fail? Because we know it's going to fail. So now we're like looking at our function, and I'm like, how can I make this piece work now? So now I'm like, yeah, I need to write the branch for, what is this, 1946 to 1964. If that's the case, then it's baby boomer. Go back to run test, clear output for terminal, upper right, run, and notice we're good. So we passed. And then we go again, and I think this is the last as far back as we go. So we say get generation, and we say 1930, and silent generation, run test, make it fail. It fails, and now we go and add the code to make that piece work. So we go here, and we're like elif year greater than equal to, this is 25 to 45. And if that's the case, then we say result equals silent generation. Clear, and then we retest. Clear, run test, upper right, run, and notice we're good. So far, I mean, this is as far as we go for generations, but what if I use like the year 2030, right? So let me go here, and I'm like, okay, what if I use the year 2030, like, well, I mean, that's not here yet, so maybe I should say invalid option, right? And while I'm here, maybe I should also use like maybe 1900, since we didn't cover that generation. So we'll say get generation. In this use case, right, we're not covering it. If we type 1900, then we should get invalid option back, right? So notice here, double quote, double quote, double quote, single quote, single quote, single quote, single quote. Python doesn't care. Like, it'll treat double quote and single quote as a sequence of characters or a string, and it'll work. So is this passing or failing? It should fail because we haven't done anything to handle years that are out of range, right? So notice here, invalid option is not quote quote, so we have to go and fix that. So if we go and look at the structure of our if, elif, else, or if, else, if, notice we need the else piece, right? So we go to our decisions here. So we cover all of these generations, and for this example, that's all we're interested in. So any other number we will handle with else, and we said result equals to invalid option. Now I can go back, clear, run test, run it, and get generation right here, still okay, right? So we've completed the function. We've tested every branch in the function. We've tested every branch. We have our test case, so we can feel very confident that if we use this in a main program, then it should be fine, like it should work. So let's go and use it in a main program. So we go here, we can safely overwrite this piece here. Maybe, yeah, we'll just write some brand new code. Year equals, so integer, capture input from the keyboard, input, and we say enter a year. And we say integer because as soon as we get that value and save it into this variable, we want Python to treat the value as whole number. So we have that. Now we are like generation equals, let me see here, decisions, get generation, and we pass in the year, and then we say print, and we can say year is and generation, right? So notice we can separate them by commas, and Python knows how to concatenate them together, put them together for us. Notice how our main is very small, and that's what programmers shoot for. Like the main is just kind of like the entry point into our program. That's where everything works, right? All the logic in this piece here is in get generation. Right here, we have what's this? Boolean expression, right? We have a Boolean expression here, operator, logical operator, and Boolean logic operator, and then we have another Boolean expression. So we're using the AND piece here. So we go back here and let's go ahead and run our program. So clear, run, enter year, 1926. 1926 is silent generation. Okay, we go 2014. 2014 is centennial. And then we're like, okay, 2025 is invalid option. And then we go 1920, which we didn't cover, invalid option, right? So now we have a program that we tested that should work, like, and minimize defects or bugs in the future. Is this method like giving us the ability to not, or like, is this bug proof? No, like we're humans, right? We'll make mistakes, but it gives us the chance to deal with fewer bugs, right? And if we have fewer bugs, then we have more time to add new features to our program. Like if it's a gaming app, the more features we add, the more our users keep on coming back. If our program is full of bugs and we don't have time to add features, then eventually they'll find the latest and greatest game, right? And that's not what gaming developers want, or gaming companies, right? Questions here?
Yeah, I have one. In the decisions.py, I noticed you put return equals to the generation. Is there, I know in the previous ones you're putting return and just the like the value. Is there a reason why you're putting equal sign for the return value?
Yeah, well, here we're just dealing with one statement, right? Like return hours greater than 40. And the recommendation when we write functions is to limit the return statements, if possible, to one statement. So here we have this block of code, but we still only have one return statement. And the reason for that is, like, as our code grows, if we know that our functions are limited to one return statement, then that helps us like find bugs in the future. We're not dealing with like multiple return statements in a function, and then we're like, oh, what happened? Like, did it return here, or did it return over here, or over here? So that's like the reason for just using one return statement.
Okay.
Mm-hmm. Other questions? Yeah, and to your question, like all of them like have only one return statement, right? And here we also have one return statement, which is what we want. I think you were shooting for like maybe we can do return here, return here, return here, return here, return here, which is not recommended. Okay, let me see here. Let me commit this. So this is if, elif, else, I'll say generation there. Commit it. Yes. And send it on to repository. Okay, so today we built on the knowledge that we have with Boolean expressions to use them in if statements. So in the previous examples, like in main, we were using if and like some variable. Let me make sure that I point out what I'm saying, right? So I'll go here. This is what I mean, like variable true, right? So that was one. Let me refresh here. So if I refresh, my other commits should pop up. And like if else, open. Okay, let me move this over here. So here we just use variable over time, but this variable is true or false because it derived from a Boolean expression. So that's why we're okay with that. However, in this last example that I gave you, so we go to decisions, we have the actual Boolean expression in the condition for the if statement, right? So now here we are building the Boolean expressions here, and we are using the keyword and, right? Like year and, right? So both of these have to be true. This has to be true, this has to be true. If one of them is false, like, or that branch doesn't run. So I just wanted to show you that there's nothing wrong with doing the Boolean expressions here, and that's usually what you see out in the industry. But you'll also see examples like this where like they get some true false value from a function, especially if it's like some complicated logic, and then they use it like in main or in another piece of the program to control the flow of controlling the program. So let me stop this piece.